Welcome back. Last lesson you learned how IP addresses and subnets work. Today we meet the two invisible services that make networks actually usable for humans, DHCP, which hands out addresses automatically, and DNS, which turns website names into addresses. When these break, the phone rings, so understanding them is core helpdesk knowledge. Picture this. You'd have to set a unique IP address by hand on every single device, and memorize the IP of every website you ever visit. Impossible. Two services rescue us. DHCP hands out IP addresses automatically. And DNS turns friendly names, like example.com, into the numeric addresses computers actually use. They run silently, until they don't. Let's start with DHCP, the Dynamic Host Configuration Protocol. It leases each device its full configuration, an IP address, a subnet mask, a default gateway, and the addresses of DNS servers. Everything a device needs to talk on the network. If no DHCP server answers, the device falls back to that 169.254 APAPA address we met last time, and it has no real connectivity. The DHCP handshake is easy to remember with the word DORA. D. Discover, the client shouts, "Is there a DHCP server out there?" O. Offer, a server replies with an available address. R. Request, the client says, "I'll take it please." And A. Acknowledge, the server confirms and writes down the lease. Discover, offer, request, acknowledge. DORA. Now DNS, the domain name system, the Internet's phone book. When you type a website name, your PC asks a resolver. That resolver works down a tree, first the root servers, then the top-level domain like .com, then the domain's own authoritative server, and back comes the IP address. The answer gets cached, so the next time you visit, the lookup is instant. DNS stores different record types, and you should know the main ones. And a record maps a name to an IP version 4 address. A Quad A record does the same for IP version 6. A CNAME record is an alias, one name pointing at another name. And an MX record points a domain to its mail server. When email won't deliver, the MX record is often where you look first. Your key tool here is nslookup, or dig on Mac and Linux. Type nslookup and a website name. It tells you which DNS server answered and the IP address it returned. Here's the golden rule for the helpdesk: if you can ping 8.8.8.8 but nslookup fails, you have a DNS problem, not a connectivity problem. Pinging by IP bypasses DNS entirely. Most DHCP and DNS problems clear with 3 commands. ipconfig/release and /renew get a fresh address from the DHCP server. And ipconfig/flush DNS clears the local DNS cache. A stale cached entry can make one site unreachable while everything else works, so flush DNS is your first move. And if a PC still shows a 169 address after renewing, suspect the DHCP server or a bad cable. Let's recap. DHCP automates addressing using the DORA process. DNS resolves names to IP addresses and caches the results. nslookup tests resolution, and flush DNS clears a stale cache. Your task: run nslookup on example.com and on your own organization's website, note the server and IP. Then run ipconfig/flush DNS and confirm the cache cleared. Finally, write in your own words how you tell a DNS fault from a connectivity fault. See you next time for ports and protocols.